Hello, calculus fans. Let's compute the directional derivative of the function x squared y cubed plus 5xy squared at the point 1, -2 in the direction of the vector 2, 3. So we've got three different components that we're dealing with here. We have got a function, we've got a point, and we have a direction. First thing we need is to compute the partial derivatives at the point 1, -2. So we compute the partial derivatives and then plug in 1, -2. So here's what the partial derivatives look like. And when we plug in 1, -2, we'll get 4 and -8 for the two partial derivatives. The next thing we need is a unit vector in the direction of v. So the vector v is 2, 3. If we compute the length of v, we'll get square root of 13. So the unit vector that we want is to take 2, 3 and divide by square root of 13. So we end up with the unit vector 2 over root 13, 3 over root 13. And then finally, we'll just use our directional derivative theorem that tells us we just have to multiply the partial derivatives by the components of the unit vector and then add those up. So we'll get 4 times 2 over root 3 minus 8 times 3 over root 13, and we get a final answer of -16 over root 13. So the interpretation of this number is that if you're standing on the surface above the point 1, -2, and you start moving in the direction of the vector 2, 3, then you'll have a slope of -16 over root 13. Notice that in the notation, we have a subscript v. That's indicating the direction that we're computing this directional derivative. Okay, that's all for now.